This video is for class 9 physics, and this is the continuation video for the numerical problems from exercise 5a. In the previous video we had completed till number 3, and from 4 onwards we are solving in this video. So let us go to the question. The question reads as: a solid of density 5000 kilogram per meter cube. So here rho s is given, weighs 0.5 kgf in air, right. So weight of the object in the air is given. It is completely immersed in water of density 1000 kilogram per meter cube, right, and you are supposed to calculate the apparent weight of the solid in water. Okay, so as you all know, apparent weight should be equal to weight in air, which is given to us, minus upthrust. So now, so upthrust is question mark. Okay, so we are supposed to find the upthrust. Let us go to its solution. Coming to the solution of number 4. The things which was given to us were the density of the solid, which was 5000 kilogram per meter cube, then the density of the liquid, which was 1000 kilogram per meter cube, right. The other thing which is given to us is the weight of the solid in air. So weight of the solid or the object, I am writing here object in air. So weight of the object in air is equal to 0.5 kgf, right. And now we are supposed to find the apparent weight. Now to find the apparent weight we need the upthrust. So to calculate upthrust we can use the formula Fb dash equals to V rho L, that is the density of the liquid multiplied by acceleration due to gravity. Now the problem here is this particular V is missing, it is not given directly, right. Now to calculate V, okay, we can use the formula V equals to mass by density of the solid. Now to find the to find the volume, we will replace the values of m, which is 0.5 kg. Okay, it follows from here, right. Since the weight is given, which is 0.5 kgf, therefore the mass will be 0.5 kg upon density of the solid, which is 5000 kilogram per meter cube. Now this kilogram gets cancelled, it goes back, decimal becomes multiplied by 1 upon 10, right, and then further cancelling it, we shall get 1000 here. Okay, hence the ultimate value of V becomes V equals to 1 upon 10,000 meter cube, right, 1 upon 10,000 meter cube. Now putting this value we shall get the upthrust, right, upthrust V, this is V rho, which is 1000, right, kilogram per meter cube, multiplied by the acceleration due to gravity. Now these 3 zeros can cancel these 3 zeros, hence my upthrust becomes 0.1 kgf, right. Now the last part, apparent weight. So the apparent weight will be equal to weight in air minus upthrust. So the weight in air was 0.5 kgf minus upthrust is 0.1 kgf, and finally we are getting 0.4 kgf, right. So this is the final answer here. This is the final answer here for question number 4. Now let us go to question number 5. Coming to question number 5, the question reads as: two spheres A and B, each of volume 100 centimeter cube, that means they are of same size, are placed on water of density 1.0 gram per centimeter cube, which also means 1 gram per centimeter cube. The sphere A is made of wood, right, whose density is 0.3 gram per centimeter cube. This is the density for the sphere A, rho s for the sphere A, right, and the sphere B is made up of iron. This is also rho s, okay, right, rho s for sphere B. So density is 8.9 gram per centimeter cube. Now from all this data we are supposed to find the weight of each sphere and then the upthrust acting on this each sphere. Afterwards we will come to know which will sink and which will float from this calculation. Then we have to give the region also, right, which sphere will float, right. Let us go to its solution. So number 5 can be written as, can be solved as, let me change the color. So let us write the things given to us, okay, for sphere A, sphere A, for sphere A, right, volume is equal to 100 centimeter cube and mass of sphere is equal to volume multiplied by density, rho s. Here the rho s is also given to us, which is 0.3 gram per centimeter cube, right, 0.3 gram per centimeter cube. Now multiplying these two values we shall get 100 centimeter cube multiplied by 0.3 gram per centimeter cube. The centimeter cube and the centimeter cube gets cancelled, hence I shall get, this decimal is removed, I shall get a 10 here, 0 and 0 gets cancelled. So my answer is 30 kg. Therefore the weight of sphere A is equal to 30 kgf, right. The weight of sphere A is equal to 30 kgf. Okay. Now we have to find the upthrust acting on A. Now to calculate upthrust we need the formula V rho Lg. So the upthrust Fb dash will be equal to V rho Lg. Now the value of V is already given, which is 100 centimeter cube. The density value is also given, which is 1.0 gram per centimeter cube, and the last one is multiplied by G. So solving this we shall get 100 gram force. So the upthrust acting on the sphere A is 100 gram force, right. Now here you can see, since the weight of sphere A is less than the upthrust, right. So therefore sphere A will float, right. Therefore the sphere A will float. Now let us see what happens to sphere B. For sphere B, the volume given to us was 100 centimeter cube, the density was 8.9 gram per centimeter cube, right, and we are supposed to find its weight. Before finding the weight, we shall calculate its mass, right. So 100 centimeter cube multiplied by 8.9 gram per centimeter cube, right. Now this centimeter cube gets cancelled, okay. So we can remove the decimal point, 0 gets cancelled, so we shall get 890 kg, right. So we shall get 890 gram, okay, it's not kg, 890 gram. So the weight will be, therefore weight of sphere B shall be equal to 890 gram force, 890 gram force. Now let us try to calculate the upthrust acting on sphere B. So the upthrust acting on sphere B when it is fully immersed will be V rho L G. Now the value of V is 100 centimeter cube multiplied by 1.0 gram per centimeter cube multiplied by G. So here you can see the centimeter cube and the centimeter cube gets cancelled, and we shall get 100 gram force as the answer. Now as you can see, the weight was 890 gram force, but the upthrust is just 100 gram force. Since the weight of sphere B is more than the upthrust on the sphere B, right, more than the upthrust. So therefore sphere B will sink. B will sink, right. I hope you understood number 5. Coming to question number 6, the question reads as the mass of a block made of a certain material is 13.5 kg, okay, it's 13.5 kg, and its volume is 15 into 10 to the power minus 3 meter cube, which is actually 15 upon 1000, okay, 15 upon 1000 meter cube. So you are supposed to calculate the upthrust on the block, the upthrust on the block, okay, when it is fully immersed, that is FB dash, using the formula V rho LG. Here V is given, right. So let us see the density of the liquid is given or not, okay, then G. Next we need to calculate, will the block float or sink in water when released, okay. If the FV dash is more than the weight, obviously it will float. if Fb dash is less than the weight, it should sink. And last one, what will be the upthrust on the block while floating? Okay, so here they are already saying it is floating. So while it is floating, what will be Fb? Okay, what shall be Fb? So my Fb is question mark. I hope you understood the question. So the density of the liquid is also given, which is 1000 kilogram per meter cube. So let us try to solve it. So number 6, things which is given to us: mass of the block is 13.5 kg and the volume of the block is 15 multiplied by 10 to the power 3 meter cube, and the last one, which is the density of the liquid, which is also given as 1000 kilogram per meter cube. Okay. Number A, now 6a, we are supposed to calculate the upthrust, that is Fb dash, which can be calculated by using the formula V rho Lg. So putting the values of V, which is 15 multiplied by 10 to the power minus 3, sorry, it is 10 to the power minus 3 in the question. So 15 upon 1000 multiplied by 1000 multiplied by G. So we shall get, after calculating, we shall get 15 kgf, kilogram force. We shall get 15 kilogram force. Now solving number B, we are supposed to find the weight of the block. Okay, so weight of the block will be number B, weight of the block, weight of the block can be calculated by using the formula mass into acceleration due to gravity. So the mass given to us is 13.5 kilogram multiplied by acceleration due to gravity. So we shall get 13.5 kgf, kilogram force. So now here you can see, since the weight of the body or the block, weight of the block is less than the upthrust, okay, which was actually 15 kgf, right. So therefore the block will float. Block will float. Now since the block floats, okay, therefore the total upthrust acting on it, which was 15 kgf, right, will push it upwards, isn't it, and some part of the body should be immersed, hence we shall get a new upthrust, okay, that is Fb. Now solving part 3, number C, while floating, the apparent weight of the block is 0, right. Is equal to 0, since upthrust is equal to weight in air minus apparent weight Okay, so I can write upthrust FB is equal to 13.5 kgf minus 0. So therefore upthrust is equal to 13.5 kgf. So this is the solution of number 6. So this much for this video. We shall do the other numbers in the next video.